Welcome to the Deep Dive. Today, we're diving into the life and work of Alan Turing. You know, the brilliant mind behind some of the most fundamental concepts in computer science. We'll be using excerpts from a Spanish-language biography of Turing. It focuses specifically on the chapter about the invention of the computer. So get ready for some fascinating history and some pretty mind-blowing thought experiments.
You know what I find so captivating about Turing is how he connected, abstract math with, the physical world of machines. He took these complex questions about logic and calculation, and he turned them into the foundation for the technology that we use every single day. It's incredible.
It really is. And speaking of incredible, this biography dives into Turing's lifelong fascination with numbers and problem solving. Even as a kid, his thinking was just extraordinary. There's this anecdote about him figuring out the best way to collect honey. It just blew me away.
Oh, the bee story.
Yeah.
Yeah, instead of just randomly searching for honey. Young Turing, he watched how the bees flew, and he realized that if he found where those flight paths intersected, it would lead him straight to the honeycomb.
Yeah.
Pretty impressive, right, for a honey-loving kid?
Absolutely. It's like he was already like this little scientist, observing, analyzing the world. And that analytical mind was further shaped by this book he read. It was called Natural Wonders Every Child Should Know. And it presented the human body as this complex machine, which really got him thinking about the relationship between the physical and the mental. Do you think that early exposure to the body as a machine played a role in his later work with, well, actual machines?
It's possible. It
Yeah.
really shows how those early influences can just totally shape our thinking. And another really important moment in Turing's life was his friendship with Christopher Morcom. He was a fellow student who shared his love for science. But sadly, Morcom died very young, and this loss deeply affected Turing. It led him to question the nature of consciousness and whether the mind could exist without the body.
Wow, that's a deep question. And one that would later fuel his explorations into artificial intelligence. Now, to really get Turing's biggest contribution, we have to go into the world of theoretical mathematics. The biography brings up this thing called the Entscheidungsproblem. Have you ever heard of that?
Oh, of course. It's German for decision problem. It was a huge challenge in math at the time, basically asking if a machine could be created to figure out if any mathematical statement was true or false. Turing's attempt to answer this question led him to invent what we call the Turing machine.
Okay, so the Turing machine is the foundation of modern computing, but I have to admit, it sounds kind of intimidating. Can you break it down for us?
Absolutely. Imagine a tape, an infinitely long tape, divided into squares like a roll of film. Each square can hold a symbol, like a 0 or a 1. And the machine has a head that can read and write these symbols on the tape. It moves left or right depending on the instructions. Does that make sense?
Okay, I'm picturing it. So it's kind of like a typewriter that follows a set of instructions?
That's a great analogy. The key is this table of instructions. It tells the machine exactly what to do, based on the symbol it reads and its current state. The machine writes a new symbol, moves the head, or changes its state. Think about it like a washing machine. It goes through different states: wash, rinse, spin, based on what you put in it and the program you choose.
Oh, okay, I get it. So the state is important. The Turing machine isn't just mindlessly following instructions, it's actually reacting to the information and changing its behavior.
Exactly. And the biography actually walks us through an example of a Turing machine in action. It really helps you visualize the process. What's really mind-blowing is that something as complex as a modern computer can be broken down into these really simple actions: reading, writing, and moving on a tape.
That's incredible. So this theoretical machine, the Turing machine, is basically a blueprint for all computers.
Yeah, in a way. But Turing didn't stop there. He went on to imagine the universal Turing machine. And that's where things get really interesting.
Okay, here's where it gets really interesting. This universal Turing machine wasn't limited to just one set of instructions, right?
You got it. A universal Turing machine can simulate any other Turing machine. Essentially, it can be programmed to perform any calculation that any other Turing machine can. It's the theoretical ancestor of the programmable computers we use today.
Wait a minute. So Turing basically invented the concept of software before there was even hardware to run it on.
Exactly. He envisioned a machine that could be given different sets of instructions, essentially different programs to solve all sorts of problems. This idea, combined with something called the Church-Turing thesis, revolutionized our understanding of what machines could do.
Okay, now you have to explain the Church-Turing thesis. It sounds important.
It is. It basically says that any problem that can be solved by an algorithm can also be solved by a universal Turing machine. This connected the theoretical Turing machines to the real world of problem solving. Any task that you can break down into a set of instructions, an algorithm, could theoretically be done by a computer. Think about doing your laundry, sorting clothes, checking labels, adding detergent, picking the right cycle. It's an algorithm, right? And it leads to clean clothes.
That's a great example. So the same principle applies to math calculations, writing code, or even writing a love letter. It's all about breaking things down into logical steps. It's amazing how Turing's theoretical work led to something so practical and universal.
Absolutely. But it was during World War II that Turing's genius was really put to the test. He went from this abstract world of theory to the very real world of code breaking.
Ah, yes, Bletchley Park, the Enigma machine. It sounds like a spy movie.
It was a race against time. The Germans were using this machine called Enigma to encrypt their military communications. Cracking this code was crucial for the Allied forces. Imagine a typewriter with rotors, each containing the alphabet, wired in this super complex, constantly changing pattern.
Yeah, the biography calls it a diabolical machine, and for good reason. Every time you press a key, the rotors would turn, creating a new circuit and changing how the letter was encoded. It makes my head spin just thinking about it.
It was incredibly challenging. And to make it even harder, the Germans changed Enigma's settings every day. They used code books with the initial rotor positions and wiring. It was a constantly evolving puzzle.
So how did Turing even begin to approach this?
He built upon the work of Polish mathematicians. They had made some breakthroughs before the war. Turing, along with a guy named Philly Knox, designed a machine called the bomb.
The bomb. Another machine based on brilliant mathematical logic. The source material explains that it was like an electromechanical simulation of multiple Enigma machines working at the same time. So it was like having a room full of Enigmas trying to crack the code.
Exactly. The bomb would systematically test different settings. Rotor settings, wiring combinations, looking for anything that would point to Enigma's daily settings.
It sounds like a brute force approach, just trying everything until something worked. Did it take forever?
It was a huge task.
Yeah.
But Turing also came up with statistical approaches. They called it banbarismus. It helped narrow down the possibilities and speed up the decoding.
So he combined raw computing power with clever analysis, a multifaceted approach. No wonder they called him a genius. The biography also mentions some funny things about Turing's personality at Bletchley Park. He chained his mug to a radiator to stop people from stealing it.
That's right. He was known for being a little eccentric. He was also a long-distance runner. Sometimes he would run the 40 miles to London for meetings.
Wow. Dedicated to code breaking and fitness. It's clear that Turing's work at Bletchley Park was crucial to winning the war.
Absolutely. Some people think that their code breaking shortened the war by at least 2 years and potentially saved millions of lives. But Turing's contributions to computing go way beyond Bletchley Park.
And that's where we start to see his vision for a more general-purpose computer, right?
Exactly. The source material talks about Colossus. This machine was built at Bletchley Park to break the Lorenz ciphers, which were even more complex than Enigma. Colossus is often seen as the very first electronic computer. It even came before the famous ENIS, but it was kept secret for years. Unlike the theoretical Turing machines, Colossus used electronic valves, kind of like vacuum tubes.
So Colossus wasn't directly based on Turing's theories, but it was a big step toward making his ideas a reality.
Exactly. Turing didn't directly work on Colossus, but he knew about it and its potential. After the war, he focused on designing a computer based on his own vision, which led to the creation of Pilot ACE.
Pilot ACE. Now this is where things get interesting.
Pilot ACE was Turing's big post-war project at the National Physical Laboratory. One of the biggest challenges back then was computer memory. The biography highlights how they used mercury delay lines. Have you ever heard of those?
Mercury delay lines. Not until I read this book. It sounds like something out of science fiction.
They were pretty ingenious, actually. Imagine a tube filled with mercury, with a speaker at one end and a microphone at the other. Electrical pulses, representing data, would be turned into sound waves, sent through the mercury, and then converted back to electrical pulses at the other end. It was a way to store data using the time it took for sound to travel through the mercury.
Wow, that's crazy. So the computer's memory was literally stored in sound waves. Traveling through liquid metal sounds a bit delicate. Not to mention messy if there was ever a leak.
It did have its limitations. It wasn't very fast. And it couldn't hold that much data. Turing's Pilot ACE used mercury delay lines, but it also used magnetic drums, which were a big step forward for storage.
The biography also mentions Turing's use of the two-address method for memory management. To be honest, I don't fully get it. Can you explain that?
Sure. Think of it like this. Each spot in the computer's memory has an address, like houses on a street. Turing's two-address method made it much faster to find the information you needed, which is super important for computers to run smoothly. It was a pioneering technique, and it kind of predicted how memory is managed in modern computers.
So he was optimizing how computers access information, making them faster and more powerful. It's amazing how he was thinking about these things back then.
He was way ahead of his time, and that's even clearer when you look at his work at the University of Manchester. He worked on the Manchester Mark II, another groundbreaking computer. This machine was a milestone because it used binary code. That means instructions and data were represented using just zeros and ones, the language of electronic circuits. It's the same system that powers every computer today.
So the Manchester Mark I was like a huge leap forward. It was using the language that computers speak.
Exactly. And with the programming manual for the Manchester Mark I, computer programming became its own field. Turing, along with others, were writing the rules for how we communicate with computers.
It's mind-blowing. He wasn't just thinking about the hardware, the physical machines, but also the software, the language that makes them work,
Yeah.
and the whole field of computer science.
It's like he planted the seeds for the entire digital world. But he didn't stop there. He was also fascinated by the question of whether machines could actually think. This led him to explore artificial intelligence, a field that he helped start.
That's right. Remember how Morecambe's death got Turing thinking about consciousness and whether the mind could exist without the body? Well, those questions stuck with him and eventually led him to explore the idea of thinking machines. It's like everything came full circle.
Exactly. Turing started by developing a model of an unorganized machine that could learn and organize itself, kind of like how the human brain develops. It was a groundbreaking idea. It challenged how people thought about intelligence.
And he approached this complex topic with his usual playful style. He even created a program that could write love letters.
That's so Turing, a brilliant mind, but also someone who wasn't afraid to explore strange ideas with a bit of humor. But his most famous contribution to AI is probably the Turing test.
Ah, yes, the Turing test. Instead of trying to define what intelligence is, Turing focused on how we could recognize it in a machine. Can you explain how that works?
Sure. Imagine you're having a conversation through a computer. You can ask anything you want, but you don't know if you're talking to a person or a machine. If the machine can fool you into thinking it's human, it passes the test.
So if I'm chatting online and I can't tell if it's a chatbot or a real person, maybe I should be thinking about Turing.
Exactly. The Turing test is all about whether a machine can convincingly imitate a human conversation. Turing thought that if a machine could communicate like a human, then it could be considered intelligent.
That's a really interesting way to think about it, and people are still debating it today, right?
Oh, absolutely. The Turing test has led to so much discussion and research in AI. The biography points out that it also kind of foreshadowed the symbolic approach to AI, where intelligence is seen as the ability to manipulate symbols, like words and language.
It's fascinating how Turing's ideas are still shaping how we think about and develop AI. But Turing wasn't just interested in computers and AI. The source material talks about his work in morphogenesis, the study of patterns in nature. That seems like a big jump from code breaking and computers. What got him interested in that?
Turing was a true polymath, always curious about the world. He used his computational thinking to try to understand how patterns in nature appear, like zebra stripes or the spots on a Dalmatian. Turing developed a mathematical model called reaction diffusion to explain how these complex patterns could come from simple chemical reactions.
So he was using computer simulations to understand biology.
Exactly. He was fascinated by the idea that simple rules and interactions could create such complex and beautiful patterns in living things. His work started the field of mathematical biology, showing how computers could be used to study not just machines, but also life itself. His influence goes way beyond computer science.
It really does. Speaking of influence, what do you think Turing's biggest legacy is? How did his work change the world?
Alan Turing's legacy is everywhere. His work on computation led to the digital age, and his work on artificial intelligence is still inspiring new research and innovation. Every time we use a smartphone, browse the internet, or use any computer, we're benefiting from his vision.
That's an amazing thought. It makes you wonder what Turing would think of our technology today. What would he be working on if he were still alive?
That's a great question. I think he would be excited by how far computing has come and all the progress in AI, but I also think he would already be on to the next big challenge, maybe quantum computing or the mysteries of the human brain.
It's incredible that one person, Alan Turing, had such a huge impact on the world.
It really is. His story shows us that asking bold questions, thinking outside the box, and being curious and exploring can lead to incredible breakthroughs. Breakthroughs that change how we live, work, and even think.
This has been The Deep Dive, and we hope you've enjoyed learning about Alan Turing as much as we have. If you want to learn more about Alan Turing,
This biography has some great resources, like books and articles, even documentaries.
yeah, we'll put those in the show notes so you can check them out. It's been amazing learning about this incredible guy.
It has, from his early love of numbers and patterns to his groundbreaking work with computers and AI.
Alan Turing really changed the world, and I'm so thankful for his vision.
Me too. He shows us that human ingenuity can lead to these amazing breakthroughs that change how we live and work, even how we think.
This has been The Deep Dive. We hope you enjoyed exploring the world of Alan Turing with us.
Until next time, keep asking those big questions, keep exploring, and never stop learning.